Hello, students. Students, in this video, we are going to discuss on design analysis of algorithm lab exercise 5, where we are going to discuss on matrix chain multiplication using dynamic programming. Generally, you all know the basics of how to multiply a matrix, right? For example, whenever we want to multiply a matrix like one matrix, say for example, A matrix is of 2 cross 2 and B matrix is of 2 cross 2, it's a square matrix, then we will multiply this, right? There is no problem because all the rows and columns are of same dimension. Let's take another example. For example, if A matrix is of size 2 cross 2 and the B matrix is of size 2 cross 3. So in this case, you can see for A matrix, the row is 2 and the column is 2, and for B matrix, the row is 2 and the column is 3. So if you want to multiply two matrix, we have to make sure that these two values should be same, which means what? The column value of A matrix and the row value of B matrix should be same. Then only we can do the multiplication. And for example, if I want to say an example, I hope you know how to multiply two matrix. For example, let A matrix be 1, 2, 3 and 4, and into I want to multiply the B matrix, that is 2 rows and 3 columns, let it be 5, 6, 7, 8, 9, 10. How will we multiply this? We will be multiplying that by 1 into 5 plus 2 into 8. So this will be the one value, and then this means this row and this column. And for the next value, this row will be multiplied with this column. So what will you get? 1 into 6 plus 2 into 9. Similarly, you will get 1 into 7 for this column and plus 2 into 10. And for this one, we'll be multiplying this row and this column. So we'll be getting 3 into 5 plus 4 into 8. And this row and this column will be getting 3 into 6 plus 4 into 9. And then if I want to multiply this row and this column, I'll be getting 3 into 7 plus 4 into 10. So this is what my multiplication of this two matrix. So finally, what will be the result I'll be getting? So if I multiply and then finally if I add, I'll get the answers like 21, 24, 27, and then 47, 54, and 61. So this is what the resultant matrix, let it be C. Okay, so when I multiply this A matrix and this B matrix of dimension 2 cross 2 and 2 cross 3, and the resultant matrix dimension is this one. 2 cross 3 will be the dimension of resultant matrix. So you can see 2 rows and 3 columns. So this is how we'll be getting the dimension of the resultant matrix. And so if you see this, how many and if I want to know what is the cost of doing this multiplication, if I want to find the cost of multiplying this two matrix A and B, how will I find the cost? So here in design analysis of algorithm, we are analyzing everything and we are computing what will be the time complexity and space complexity. So we want to analyze how much number of multiplication or what is the cost to do multiplication between these two matrices. So here to analyze the cost, what we want to find is we want to find how many number of multiplication has happened here. So based on that, we will be knowing the cost of multiplying this two matrix. So how to find the cost is, so you have to find how many multiplication is done. So here you can see for this we have two multiplication, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So totally 12 matrix, 12 multiplication is required. So how do we calculate here is, we can do like this: 2 into, and this one, the rows into here, this 2 and this 2 is similar, same, right? So from that we'll take 1 2 into this column value 3. So equal to 2 2s are 4, 4 3s are 12. So totally we require 12 multiplication to multiply this two matrix A and B of dimension 2 cross 2 and 2 cross 3. So this is how we will be finding the cost of multiplying this two matrix. So what you have to do, you have to take this 2, this row into, from this you have to take only, because both the value was same, right? So let us take only one among that. So 2 into 2 and this 3. So 2 into 2 into 3 will be 12. So this is how we will be calculating the cost. And and we know what is the resultant matrix size also. So this is the basic of multiplying any two matrix, and you have to keep this in your mind. So multiplying two matrix is not a big deal for all of us, because you know the basic of it. So but here we are going to concentrate on matrix chain multiplication. So what is this chain multiplication? When we have more than two matrix, for example, if you want to multiply three matrices, or if you want to multiply four matrices, or if you want to multiply five matrices, then how does we multiply, and what is the cost of multiplying all these things? That's matter here. That's what we are going to discuss here. And for example, if I want to multiply three matrix, I cannot multiply all the three matrix at a time. Only we can multiply two matrix at a time. So we have to decide which two matrices need to be multiplied, and then which matrix will be multiplied with which one. So that's what we want to discuss in chain multiplication. So let's take an example. Let me take an example like let us take some three matrices. Okay. For example, let me take three matrices. Let it be A1 matrix, A2 matrix, and A3 matrix. So I have named three matrices with the name A1, A2, as I have named here as A, B, right? So here I have named this three matrix as A1, A2, and A3. And let us discuss about the dimension of this matrix as well. So let me take the dimension of A1 matrix is 2, 3, and the dimension of A2 matrix is 3, 4, and the dimension of A3 matrix I have considered is 4, 3. Okay, so this is what the dimension. And now if I have this matrix, so as I already told, we cannot multiply this three matrix together. So I can multiply only two at a time. So how can I do? So what can I do? And already one thing you have to remember, whenever I want to multiply two matrix, the column of the first matrix and the row of this second matrix should be same. So I have two possible ways to do the multiplication here. One is, first I'll multiply A and A1 and A2 first. Okay, I'll multiply this two first, and the resultant, what will be the resultant of this matrix? So the resultant of this matrix will be 2 cross 4 matrix, and this matrix then will be multiplied with the A3 matrix, which is of 4 cross 2 matrix, and then we'll be finally getting a resultant matrix of 2 cross 2. So A1 and A2 is multiplied. That result, what we get, will be multiplied with this A3 matrix, and finally we'll be getting 2 cross 2 dimension matrix. So this is one possibility. What is the other way of doing this multiplication? I can also do like this. First, I will multiply A2 matrix with A3 matrix, and then this result will be then multiplied with A1. So this is another possibility, another way of doing multiplication. But the result of both will be same. The value which I get here and the value which I get here will be same. But what matters there is the number of multiplication taken to multiply these three matrices will be different. So for example, in this A1, A2, A3, first we multiplied A1 and A2, then we multiplied A3 with that. So the number of multiplication required there may be different. And here what we did, first we multiplied A2 and A3, then we multiplied, the result is multiplied with A1, and the result of this is multiplied. So the result will be same, but the number of multiplication required to do the same will be differing. So that's the matter. So we want to find which will be taking less number of multiplication to achieve the result. So that is our objective. So that's what we are going to find with the help of dynamic programming. So what is dynamic programming? We have to try all possible cases, and among all possible way of multiplying the matrix by by parenthesizing them, then and among that we have to find which is the best possible or minimum cost, which is creating the minimum cost, that will be selected. So that is called dynamic programming. Trying all possible ways and choosing the best one is dynamic programming. So we are going to solve this matrix multiplication with dynamic programming method. So let's see with an example so that you will be understanding very well. So here one more thing, for example, here when I have two matrix, when I have three matrix, how many number of uh, possibility I will get to do the multiplication also you should know, right? So how will we calculate that is, for example, here in this case, let me say here in this case, here we have three matrices, right? Here we have three matrices. So by seeing manually, we can see if I have three matrices, the possible number of parenthesization for this three matrices only two. One is this way, another one is this way. But everything we have to derive it mathematically. That's deal good, right? So what I can do is to find the number of possible combination for three matrices. We know in maths we can do the combination by the formula 2n c n divided by n. So this is what the formula to find the number of combination. So here when we do with the matrix, this n value will be taking always by n minus 1. So that is how we'll be taking the n value. So when I substitute here our n value, the number of matrix we have is 3, but we said we are going to take it as n minus 1. The n value here we are going to take as n minus 1. So what is the answer here? I'll get is 2 into n minus 1 c n minus 1, okay, and divided by n. Here when I do this n plus 1, here we'll say n minus 1 plus 1. When I apply here n minus 1, here also n minus 1, here it will be n plus 1. So n is taken as n minus 1, so this plus and this minus will be subtracted. So what will be the formula here? Will be getting 2 into n minus 1 combination of n minus 1 divided by n. So here let us apply the values for this n and let us see what is the value we are getting. So here the n value we have is 3. So 3 minus 1 is 2. So 2 into 2 c n minus 1 is 2 divided by n value here is 3. So what will be, how can we rewrite it? So I can write this in the way like I can write 2 into, so I'll be writing 2 into 1 divided by, here also I'll get 2 into 1 divided by 3, right? So here if I do this one and this one will be cancelled. Wait a minute. So here 2 into 2, sorry, what, how can I solve? 1 second. So this can be written as, rather than writing like, I'll solve like 4c2 divided by 3, right? 2 2s are 4, so I can write like this, 4, 2 2s are 4, 4c2 divided by 3. This can be written as 4 into 2 divided by 2 into 1. You might have learned it from your maths class, right? So this 4 and this into 3. So we can write 2 times, 4 into 3 and this 2 into 1. So this 3 and this 3 will be cancelled. So we'll be getting 4 divided by 2 and it will be like 2. So two possible way of parenthesization when we have three matrix. Let's see with one other example so that it will be clear for you. Let me take three matrix and let us find how many number of combinations you will be getting. So let me take a bigger value itself so that you will be clear in it. So let's take a 4 matrix. So, okay, I'm going to have 4 matrix. So if I have, for example, if I have a matrix like A1, A2, A3, A4, and how many number of possible combination I can make when I have this 4 matrix. So if I do manually, how will I write? First combination is like A1, then A2, then A3, A4. So this is one possible way, which means what? First A3 and A4 is multiplied and then A2 is multiplied with this answer. Finally, A1 will be multiplied with this answer. So this is one way of parenthesizing. What is the second way of parenthesizing? I can write A1, then I'll write A2, A3, and then A4. So this is another way of doing, which means what? First I'll multiply this 2, then the result which I get here will be multiplied with this, and finally this a1 will be multiplied this. This is the second way. And what is the another third way I can write is, I will write a1, a2, and then I'll multiply a3 and a4, and finally we can multiply this both. So this is the third way. And what other possibility I have? Fourth method I can write is a1, and then I'll multiply a2 and a3 like this, and finally I can write multiply this both. Final answer will be multiplied with this. Earlier we multiplied this 2 and then we multiplied with this. Here this 2 first multiplied with a1, then we finally multiply with a4. And the fifth option I can have is, I'll multiply a1, a2, this result will be multiplied with a3, and this final result is multiplied with a4. So these are the different possible parenthesization when I have a 4 matrix. But this we manually did, right, by changing the parentheses here and there. We find it. So mathematically also we have to calculate how many number of possible parentheses I can make when I have 4 matrix. That's also very important. And one more thing you have to remember is, whenever we do a matrix multiplication, it is an associative multiplication. It is not commutative. What it means, for example, associative, I can do uh, uh, like a1, a2 is multiplied in this order, for example, and this is equal to for example a3. So what I can do, I'll multiply a1 and a2, then I can multiply with a3. This is associative. Also I can do a1 and a2, a3 multiplied like this. And for example, this is associative, but matrix multiplication is not commutative, which means what? For example, you have two matrix AB is not equal to B. So we cannot do this kind of matrix multiplication. So we have to maintain this order. It is associative. It is like you can multiply A and A2 then with A3, or A2 and A3 is first multiplied, then it is multiplied with A1. You cannot change this order like A3 into A2. This is not possible. So matrix multiplication is only associative. It is not commutative. Okay. So let us apply this in a formula and let us find how many possible number of parenthesization I can do when I have 4 matrix. So what is the formula I told you? So the formula is, you should have n minus 2 into n minus 1 c n minus 1 divided by 2, right? That is what the formula which we have. So here the n value here we have is how many number of matrix we have? Totally 4. So 4 minus 1, so n minus 1, so 4 minus 1 is, we'll be having 3. So what will be the answer? We'll be getting 2 into 3 c 3 divided by the n value is 4. Sorry, here the n, it is n, right? N value is 4. So when I we will be getting 2 3s are 6 c 3 divided by 4. So when I solve it, how will I get? 6 into 5 into 4. So 3 possibly divided by 3 into 2 into 1 divided by 4. This is how we'll be expanding this combination. So this 4 and this 4 will be cancelled, and this 2, and here 2 3s are 6. So here, so 3 into 5 is equal to 15 divided by 3, and the answer is 5. 5 3s are 15, so answer is 5. So whenever I have a matrix of size 4 matrix, the number of possible parenthesization I'll be getting is 5. So that is what we have written here. So when we have 4 matrices, the number of possible parenthesization I can have here is 5. So that's what we have derived also, right? Okay. I hope you got it. So this is what the different possible way. So the objective here is, all the 5 way of parenthesization will help us to give the same result, but the cost is very important. So cost is here. What is the cost? The number of multiplication required to do this type of parenthesization or this type of parenthesization. Everything will be making some difference. So let us discuss that with an example so that you will be very clear what is actually happening here. Okay. So let us take an example. So let us take 3 examples. Okay. Example is, so let me take a matrix A1, A2, A3. Okay, three matrix, we have to do the multiplication. So we know when we have three matrix, there are two possible way of doing the parenthesization just before we saw here, right? One parenthesization is of this type. Multiplying A1 and A2, then the result will be multiplied with A3. The other one is A2 and A3 is multiplied, then A1 is multiplied with the resultant answer. So these are these two possible way of parenthesization. So let us say, what is the let's take the dimension of A1 as 2, 3, and the dimension of A2 is 3, 4, and let us take the dimension of A3 as 4 and 2. Okay, so let's take this as an example. So always you have to make sure whenever I want to multiply two matrix, the column here and the row should be same. Okay, so let us first do this 2 multiplication, and then let us multiply the resultant with the A3. So if I want to do this, one more thing we'll do, let us give some name to the dimensions. So let it be D0 and let it be D1. Both the values should be same. So for this also let me name it as D1. This let it be D2, and this should be same, right? So let me give it as D2, and let me name this as D3. Some name I have given. Okay, so for all these dimensions of this matrix, so first what we have to do, we have to multiply this two matrix. So how will, if I want to multiply, we want to find the cost, that is our objective, right? So if I want to find the cost, I want to earlier I showed you how to find the cost, right? So how to find the cost, we have to multiply these values. What are the values? 2 into 2 into 3. So that will give the number of multiplication required. Here we saw that, right? Same thing, let us do here also. So how will we do here? So if I want to multiply this, so we'll be getting 2 into 3 into 4, which means this row and this from this two values we'll be taking one value, that is 3 into 4. So we can say 2 into 3 into 4. 3 4s are 12, and 12 into 2 we'll get the answer as 24. So the cost of multiplying the matrix 1 and 2 is equal to 24, right? And then here this side we didn't do any multiplication for A3, right? So the cost of multiplying the third matrix is 3 comma 3 is equal to 0. Okay, so this is what we are finding. So when I multiply this two matrix, the cost, which means the number of multiplication required to multiply A1 and A2 is 24. And the first time this is not multiplied with anything. So the third matrix, the cost is 0. Now what we have to do, the result we got from A1 and A2, what will be the resultant matrix? 2 cross 4 matrix you will be getting, right? So 2 cross 4 matrix, and A3's dimension is 4 cross 2. Now we have to multiply this both. So when I multiply this both, what is the dimension actually? Here it is D0, this is D2, this both is D2, and this is D3. So when I multiply this both, how will be getting the cost? So we want to find this like 2 into 4 into 2, right? So we want to find it. So total cost, so 4 2s are 8, 8 2s are 16. So already we have 24 for multiplying this two. So finally we got this. So what are the things we multiplied here? Let's take this. So what are the things we did for multiplying this through matrix? First we multiplied C cost of 1 comma 2 matrix plus cost of 3 comma 3, then plus what are the other things we did here? Then finally the resultant of A1 and A2 is multiplied with A3. So that is what we did. 2 cross 4 cross 2 equal to 16. So what is 2 4 3? That is, we can denote here as D0 into D2 into D3. So what is the cost of multiplying 1 comma 2 matrix is 24. So we got 24. What is the cost of multiplying the cost of this matrix? We didn't do any multiplication there, right? So it is 0 plus what is D0? That is 2 into what is D2 here? That is 4. So into 4 into what is D3 here, that is 2. So when I do 24 here, when I get multiply this, 2 fours are 8, 8 twos are 16, 16 plus 24, here we will be getting the answer as 40. So if I want to multiply this 3 matrix by parenthesizing here, I will be getting the cost as 40. Okay, I hope you got it. This is very important. This is what the mathematical calculation we did to calculate this. Okay, similarly, let us do for the other parenthesization also. So how will we do the other parenthesization? This is one way of doing parenthesization. The other way we did it, so first we will be multiplying A2 and A3, and that result we are going to multiply with A1. So that is what we are going to do. So again, we know what is the dimension of A1 is 2, 3, the dimension of A2 is 3, 4, and the dimension of A3 is 4, 2. Okay, this is what we have to do. So first we have to do multiplication of this 2. So if I want to find the multiplication of this 2, how will I find? 3 into 4 into 2 already we discussed. So the answer will be 24. So how will I write? First I have to say cost of multiplying which two answers? First I have multiplied the cost of, one second. So for multiplying the first one, 1 cross 1, this matrix. Okay, so that plus that is multiplied, that get added with, okay, then this, sorry, this one. So that is added with this one. What is the cost of multiplying 2, 3 matrix? So what is it? 0 plus here we get 24. So when I multiply this, okay, this is what we get in this step 24. So when I multiply this two matrix A2 and A3, what is the resultant matrix I'll get? 3 cross 2 matrix. And this want to be multiplied with A1 matrix. So what is the dimension of A1 matrix? 2 cross 3. Okay, so when I multiply this two matrices, so what will I get? This two should be same. So how will we get the number of multiplication? 2 into 3 into 2, right? 2 3s are 6, 6 2s are 12. So 12 multiplication is required. So how will I write this? This is, so if I write the dimension here, this is D0, this is D1, this is D1, this is D2, this is D2, and this is D3, right? So here, what is 2? 2 denotes D0 and 3 denotes D1. This is also D1 and this denotes D3, right? So how we calculated this? First, we took cost of the first matrix, this one A1, plus the cost of second matrix of multiplying 2 and 3. Along with that, after I get the result of this, the resultant matrix I get is this 3 cross 2 matrix, 3 cross 2 matrix that need to be multiplied with this. So what are things we multiplied there? D0 into D1 into D3. So that is what the resultant multiplies, right? D0 into D1 into D3. So this is what we got. And cost of multiplying this was 0 because we didn't do any multiplication there. And cost of multiplying this 2 and 3 is 24. And then plus 2 into 3 into 2. Right? So when we multiply all this thing together, what will be the answer we'll be getting? Here is 36. Okay, so when this is what is the finding we got from here? So both are same matrix only, A1, A2, A3 are same matrix. The result we'll get also same, but the number of multiplication required when I do the parenthesis like this is 40. And when I do the number of multiplication required when I do the parenthesis here is 36. Okay, so which is cost effective when I compare this to is 36. So here when you see the difference is very small, the cost difference is very small amount, right? 36 and 40, it's not a big difference. But when I want to multiply very big multiplication, right? For example, if I want to multiply 10 matrix like A1, A2, A3 up to A10, then how many number of possible parenthesization I will get? And the every kind of parenthesization will create different kind of cost also. So that make a huge difference in computation. So we have to find, we have to try all possible parentheses, and then we have to find which is the best among that by the help of this dynamic programming. Okay, so that was the objective. So first for that, to calculate all this, we have to find a formula for it, a mathematical representation for this parenthesization to calculate the cost. So that is our next objective. Okay, so I have showed you two demonstration. One demonstration what I told you by parenthesizing A1 and A2. Here we did parenthesization for 2 and 3, and then we multiplied with the other one. So by doing this two, we got one mathematical notation. From this we are going to make this formula. Okay, so this will help us to find the cost value for between all different kind of parentheses. So always you remember, if you want to do, if you have a chain matrix multiplication, only at a time we can do only two matrix multiplication. All the matrix cannot be multiplied at the same time. So there comes the problem of parenthesization, and we want to find which parenthesization is the best one. So from this representation, okay, this representation, we want to derive a formula. So here again, here also we got another representation when I use another kind of parenthesis. So from this, we have to generalize, or we have to derive with an equation. So how will I derive it? Let's see that. So for example, if I want to multiply two matrix, say for example like this. Let us take a common terminology now instead of specifying like this. If I want to multiply between two matrices, okay, for example, here the matrix is 3, one, A1, A2, A3. Sometimes 4 matrix multiplication, A1, A2, A3, A4. So here, how will we represent? Let's take this example. So let us take to multiply from the matrix from I to J. How will we represent? Okay. So if you see in this example, let me show one thing. You see here, this value can be taken as I. Okay, this value is I, and this value we can taken as J. And here you can say this is some K value, this is K plus 1 value. And then we can see this 0, this is this 0, D0, right? D0 is 1 less than this I value, so I can say this as with the representation of D I minus 1. And what is this 2? 2 here is K. So I can say it is dk. And 3, what is this 3 value here? It is j value. So I can say dj. Okay. So here I and 3. So if I want to multiply from the matrix 1, 2, 3. So how will I divide it? First I have to find the cost of I and k. And then with k plus 1, the next value of k plus 1 to j, plus this d0. 0 means it is 1 less than value of I. So di minus 1 into 2 means this k, dk, and 3. 3 is the notation of this j's value. So we can say it as dj. Same thing you see in this notation also will get the same thing. If you consider here, it is the I value, this is the j value, this is, let's take as a k value, this is k plus 1 value, right? A same thing there. And this can be what we said for this, it is di minus 1. Here I value is 1, 1 minus 1 is 0, and 1, what is this? This is dk, this k value. And this d3, what is d3? It is dj's value, j value is 3, so here also we got it. So we got a common terminology to represent it as a formula. So let us represent this as a formula and see how does it comes. So how can, from this, how can I generalize this term? If I want to multiply some chain matrix like 1, 2, 3 or 1 to 4. So I take that as 1 to j. So here I can say as cost of, so okay, let me say here as cost of, what is that? I comma k plus cost of k plus 1 comma j then plus di minus 1 into dk into dj. Okay, so here what we did in the previous case, we want to multiply three matrices and we calculated the cost. And from this, what is the best way we told which have the less cost? That was taken under consideration. So if I multiply first A2 and A3 and then that result when I multiply with A1, I'll be getting the best minimum cost, right? So whenever I am multiplying with the different matrix, what I have to do from this, I have to take the minimum value. So from this, I have to take the minimum value, and I can also should say what is the k value. So if you see here in this example, the k value will be greater than or equal to I, and the k value should be less than j. So that is how it will be coming. So here, okay. So here you can see k value will be greater than or equal to I and k value should be less than j. So here I can say always this k value will be always greater than or equal to I and it will be less than j. So okay, so this is how the k value will be ranging. So for different k values, we have to find apply this cost function, and we have to choose which is the minimum one, and that way of representing parenthesization can be taken into consideration for doing the chain matrix multiplication. So this formula is very important. So this will be helping us to find the different possible way of calculating the cost when we have different combinations of parenthesization. Okay, so let's do with this formula. Let us apply this for a particular example and let's see how does it work. Okay, let's take an example. And we will be calculating and we'll be saying, so what is dynamic programming? I told you is dynamic programming means we will be finding all possible way of parenthesization, then and we'll be calculating the cost and we'll be choosing the best among that is dynamic programming. So here also we are going to find the cost for all possible calculation, and then from that we will be choosing the best parenthesization. So let us do this mathematically, calculate the cost for all possible parenthesization, and then we'll be taking the minimum value among that, and then we will be knowing which parenthesization is the better one to calculate the cost, okay, to do the matrix multiplication. So let us take an example with 4 matrix. So don't forget this formula. So you can easily remember the cost of I comma j plus cost of k plus 1 comma j plus di minus 1 into dk into dj. Okay. So always you can see this value and this value will be same here. This value 2 and here will also be 2, and j value here and the j value here will be same, and the k value only will be changing. So here the k value is 2, here the k value is 3. Okay. So let's write with an example so that you will be clearly understanding. Now let us take some 4 matrix and let us calculate it with a formula, okay, and find all possible combination cost. So let us take the 4 matrices A1, A2, A3 and A4, and let the dimensions of A1 is 3 cross 2 and then 2 4 and 4 2 and 2 5. So always remember this two should be same, this two should be same, and this two should be same, which means the column of the first matrix and the row of the first matrix should be same, then only we can do that multiplication. And let us also give this dimension name D0, this is D1, both are same. Here we can say it is D2, here we can say D3, and that is D4. Okay, so now let us find the value of, okay, let us start applying this equation for all this combination. Okay, so to find the minimum cost and to store it, let us take two tables. One is to store the cost, another one is to store the k values, because we have to find for all possible k values. When we have to find which is the minimum, that one we have to take, right? So this k value only tell us in which place we want to do the parenthesization. So okay, for that we are going to also maintain two tables. Let me draw two table. So here it is a 4 matrix, right? So for that, let me take 4 rows and 4 columns. So this is 1, 2, 3, and 4 columns. Then we have 1, 3, 4 rows as well. So it is 0, 1, sorry, we will start from 1, 2, 3. 1, 2, 3, 4, and here also 1, 2, 3, 4. So let us use this matrix to store the k value, and let us use any name you can give. Okay, just we have used k here, or yes, or whatever value you want you can give. So let us take another table to store the cost of multiplying between different matrices. So here again we will be giving the numbering from 1, 2, 3, 4, 5, sorry, again here first row 1, 2, 3, and 4. Okay, okay, let's start calculating. So we are having many different possible ways when we do the calculation. So how we have to start finding from which I values and j value we have to start is when we find the difference between I and j value. First we have to start with the minimum difference. For example, if I find the difference between 1 and this one, 1 and 2, 1 and 2. So we know already, if you see here, when the I value and j value is same, the cost is always 0. See here also, when I value, and because there is no multiplication will be happening, right? So directly you can say the cost of multiplying 1 and 1 will be 0. The cost of multiplying this is 0. This is 0. All the diagonals value will be 0, right? Then for example, then we have to fill all this upper diagonal values. Okay, so this one we are not going to fill, so we can write it in rotated format also. Somewhere you can see the stable representation in a cone shape or a triangle shape also. Whichever is comfortable for you, you can use it. So here already we saw if the I value and j value is same, which means there is no need to do multiplication. There are not, we didn't do any multiplication. That is why here for 1 and 1, 2 and 2, then 3 and 3, and 4 and 4, we make it as 0. Then when we find the difference between this row and this column, 1 minus, let us take 1 minus 2. What is the difference? 1. And 1 minus 3, the difference is 2. 1 minus 4, the difference is 3. So first we have to find the cost calculation for the minimum differences. For example, first we will calculate the cost between the matrix of 1 and 2. And then next one, this one, 2 and 3. The difference between 2 and 3 is again 1. Then 3 and 4. 4 minus 3 is again 1. So for all this combination, first let us calculate the cost using this formula. Okay, so why we are doing like that means it will be ease our works to find the answer for the remaining. So for that only we are going to do like that. So first what we have to do is we have to find the cost of multiplying matrix 1 and 2 for every possible. So let us say cost of multiplying the matrix 1, 2. Okay, so this is the I value and this is the j value. So if I represent here, how will I will be taking the minimum value, and the k value we have to range. Also here already the formula for k value, you know, the k value will be greater than or equal to I and less than j. So here what will be the k value? So if I say the k value should be greater than equal to I value, here is 1, and what is the j value? It should be less than j value, right? J value here is 2. So here you can see I value we have taken as 1, j value is 2. For this particular value we are going to calculate, right? So if you find the range of k value which is greater than 1 and k value which is less than 2, what is the only value you have? K value is 1. So we are going to calculate when k value is 1. I hope you understood. So for this particular range, k value greater than or equal to 1 means I can take k value as 1, and less than 2 means 2 we cannot take, then only 1. So k value here in this case we have only one k value, and let us substitute this here according to this formula. Okay, according to this formula we are going to substitute. So minimum of this one. So first of c of ik. So how will we find it? So cost of, first is C of and I and K. So here the I value is what? 1. And what is the K value we have taken? That is also 1. plus, then what is the next cost value? K plus 1 comma j. What is k plus 1? It became 2. And what is the j value here? We have taken 2. 2. Okay, and then plus, what is the other values on the equation? Di minus 1 into dk into j. So here what is I value? I value is 1. So 1 minus 1 is d0 into then dk. What is dk here? K value we have taken as 1. It is 1 into what is the dj value here? J value here we taken as 2. Okay. So this is what the equation of this. So now let us calculate for cost of 1 and multiplying 1 and 1 matrix. What is the cost? 0. And then cost of multiplying 2 and 2 matrix. So 2 and 2, that is 0 plus. Then we have to find what is D0. So what is D0 here? It is, so here you can see the dimension D0 is here 3. So 3 into, what is the next value? D1. What is D1 here? 2. 2 into, what is DJ here? DJ is 2. D2. So what is D2 here? 4. So it is 3 into 2 into 4. What is the answer? 24. So if I do the find the cost of multiplying the matrix 1 and 2, I got is 24. So what I can do, I can substitute this value 24 here in this place. So what will I do here? I'll put 24 here. Okay, so we did it. What is the next one? We have to do 2 and 3. So again 2 and 3, if you find the difference, it is 1. Why I am choosing like this? Then only we can easily calculate this cost. Calculating cost of 1 comma 1 2 comma 2 is easy, right? Because already we know if I and j value is same, there is no multiplication, so directly we will be getting the answer for it. So now let us do the calculation for the next value. So if I do it, what will be the value I'll be getting? So let me say it's cost of. Now let us take the I and j value as 2 and 3. So 2 comma 3. So here this is the I value and this is the j value, and I want to find, here there is only one value, right? So we can directly take it. That's the thing. And here what will be the k value? K value should be greater than or equal to, I value here is 2 and k value should be less than j. So here what is j value? J value here is 3. So what is the k value I'll be getting? K will be k greater than or equal to means I can take k as 2 and it should be less than 3. So less than 3 means 2 only. So again here we have only one k value. When k value is 2, we have to find it. So here also we have only one k value. Let's apply in the same formula. So first I and k. What is the I value here? 2. What is the k value here? 2. Plus C cost of I k plus 1. K plus 1 means 3. This is the k value, plus 1 means 3, comma j value. What is the j value here? 3. Plus d of I minus 1. What is I minus? I value is 2. Minus 1 means I'll get d1 into, and dk. What is dk value here? 2 into dj value is 3. Okay, so let us do this. So when I apply the value of this one, when I and j value is equal, then the cost of multiplying this is 0. There is no multiplication, and here 3 and 3 means again 0. Plus what is d1 here? D1 here is 2 into, what is D2 here? It is 4. And what is D3 here? It is again 4. Okay, so when I do solve this, what will be the value I'll be getting? Is 16. What is the rate? Sorry. D1 is 2, D2 is 4, and what is D3? D3 is 2, right? Sorry. Here we have D3 as 2. So 4 to the 8, 8 to the 16. So the cost of multiplying the matrix from 2 to 3 is 16. So we can write it in here. 2 to 3, we got the answer as 16. Okay. So that is also over. What is the next minimum difference? 3 and 4. So 4 minus 3, we again will be getting 1. So let's complete that as well. So we are going to do calculation for cost of, what are the two values? This 3 and this 4. So difference is 1. So 3 and 4 let us do. 3 comma 4. And this is the I value. This is the j value. Let us do that. So you want to find the minimum. Now what will be the k value? It should be greater than or equal to I. I value here is 3 and it should be less than j. J value is 4. Again he will be getting only one value for k, that is 3. And let us apply this to this equation. So what is first? C of I comma k. So what is I here? I is 3. K value is 3 plus the cost of k plus 1. What is k plus 1? K value is 3 plus 1 means 4 comma j. J value here is 4. Plus then d of I minus 1. What is I here? 3. 3 minus 1 means it is 2 into dk. What is dk here? K is 3. So d3 into dj. What is the j value here? 4. So d4. Okay, now we have to write again the values for it. It will be 0 plus this also 0 plus what is d2 value here? If you see, it is 4, d3 value is 2 and d5 4 value is 5. So you can see here. What is d2 value? D2 value is 4, D3 value is 2 and D3 value, D4 value here is 5. Okay, that we have substituted here. And when you multiply this, 5 2s are 10, 10 4s are 40. So if you find the cost of multiplying the matrix 3 to 4 is 40. So let us substitute here in the table. So here we will be getting answer as 40. So we finish this diagonal value. Already this diagonal is over, then this diagonal is over. This diagonal is the minimum difference between I and j value. The next one, let us, what is the next thing we want to find? 1 and 3. So next minimum difference we have to find for this diagonal. Okay, so this diagonal we have completed. And the next diagonal we want to find is for these two values. So 1 and 3 and this is 2 and 4. So let us find the difference between one. We will be finding the cost functions of 1 comma 3. So let's do that. 1 comma. Okay. So first let us find for 2 and 4. Okay, this value we'll find. What is this value? And then we'll go for the next one. So if you find it, let us say, what is the C cost of 2 and 4? This value. What is this value? This 2 row and 4th this value. Okay, the difference is 2 again. So we'll be finding that. If you do that, so we want to find the minimum value, and in that what will be the k value again? The k should be greater than or equal to I value. I value is here 2 and j value is 4. So 2, and it should be, k value should be less than j. J value here is 4. So what are the k values we will be getting? So k value is less than or equal to 2. So it can be 2. And if I put the k value as 3, it is less than 4. That is also okay. But I cannot take 4, right? Because 4 less than 4 is wrong. So I can give the k value as k equal to 2 and also k equal to 3. So we have to calculate for both the values. When k equal to 2, what is the value? And when k equal to 3, what is the value? For both you have to find. And among that, you have to find which is the minimum value. That you have to substitute in the table. So first we know C of I comma k value. So I here is 2. What is the k value? 2 plus cost of k plus 1. K plus 1 means 3, comma, what is j value is 4. Plus then d of I minus 1. I value is 2 here. Minus 1 means d1 into dk value is 2 and then j value is 4. So we know already the value 2 cross 2 means for same value the multiplication, no need of multiplication. Then C of 3 comma 4 already we found it, right? It is 40. So here you can see we found Cost of 3 and 4 already we found the value as 40. Plus, and what is the D value here? D1 value is 2 if you see there, and D1 value is 4 and D4 value is 5. So if you calculate, you will get the answer here as 2, 4, and then if you find, you will get the answer as 80. Similarly, we have to do the same equation when the k value is 3. So C of I value, what is the I value here? 2, and the k value is 3, plus k plus 1. C of k plus 1 means 4, 4 comma j value is 4, plus di minus 1, I was 2, so d1 into dk value. What is the k value here? 3, into dj value is d4. So if you substitute 2 comma 3, what is the value of 2 comma 3? Already we found the value here is 16. So we'll apply it. 16 plus, here it is same, so 0 plus, what is d1 value? If we find it is 2, d3 value is 2, and d4 value is 5, and if you multiply and add, you will get the answer as 36. So here itself you can understand, when the k value is 2, the cost is 80, and when k value is 3, the cost is 36. Among it, you have to find the minimum value. So the minimum value here we can find is 36. So what you have to do, in the place of 2 and 4, you have to substitute 36. So here with the table 2 and 4, we have to substitute here 36. Okay, and similarly now we have to find the value of 1 and 4. So before we find 1 and 4, we have to find for 1 and 3 as well. Similarly, same way you have to do. When you find, you will be getting 28. Okay, I think point of time, you just do the same thing, you will get. The last one we want to find is this value. So we want to find the cost of multiplying the matrix from 1 to 4. That is we are going to calculate now. One second, let me take this down. Okay, so let us do the calculation for the next value. Cost of C of, what is this value? We have to find 1 and 4. So I value is 1, j value is 4. So 1 comma 4. So how will you find? First we have to find what is the k value, and based on the k value we have to find the remaining two values. So if you find it, what will you will get? Equal to minimum of, we have to find when the k value should be greater than or equal to 1, and it should be less than j, that is 4. So what are the k values I will be getting? K value can be 1, k value can be 2, and k value can be 3. 3 values will be getting. So we have to find for all these 3, when k value is 1, when k value is 2, and when k value is 3. So we have to find all these 3, and from that we have to choose which is the minimum one. So if you calculate this, you will be getting cost of I value here is 1. What is the k value? 1 plus cost of k plus 1, that is 2, and I value here is, j value here is 4, plus di minus 1, that is I value is 1, 1 minus 1 is 0, so d0, k value is d1, j value is d4. So if you substitute the values, you will get 0 plus, already 2 comma 4 already we found it is 36, plus 3 into 2 into 5, will get the answer as 86. Similarly, when k value is 2, we'll get uh, I value 1, and here the k value is 2, plus k plus 1 means 3, comma j value is 4, plus di minus 1 0, into k value here is 2, into dj value, that is 4. So when you substitute the values, I1 already we found 1 comma 2, that is 24, 3 comma 4 also we have already found it is 40, plus 3 into 4 into 5. The answer we'll get is 124. Similarly, When you substitute, when the k value is equal to 3, so we can answer cost of I value is 1 and k value is 3 plus C of k plus 1 means 4, j value is 4 plus di minus 1 is 0 into dk value here is 3 into dj value that is 4. J value is here is 4, right? So what is the value of 1 comma 3? If you find there, it is 28. Here it is 0 plus d0 is 3 into 2 into 5. If you multiply and add, you will get the answer as 58. So now you can see we have three different cost values. So which one you have to choose for different three k values? We have three different cost value. So already we know in the equation we have told we have to take the minimum out of it. So what is the minimum value out of all these things is 58. So in this table we can substitute here. In this place you have to put the value as 58. And you should I also forgot one thing here. For which k value we did all this value also you have to denote, because k value only will help us to say in which place we have to put the parenthesis. Okay, so what will be our k value? We have to note, based on that we have to make. So if you find when we did for 1 and 2, what is the k value? You can see here 1 and 2, the k value is 1. And when we did 2 and 3, the k value 2 and 3, the k value we got is 2. And then here if you see for 3, 4, what is the k value? 3. So 3 and 4, the k value is 3. And similarly, here we will be getting the k value as 1. Here the k value is 3. And here final one, what is the k value we chose here, which is having the minimum 158. So 58 we got when the k value is 3. So here we have to make the k value as 3. Okay, so from this k matrix only we know in which place we have to make the parenthesis. Okay, so what I will do is, okay, sorry. Let us, you remember this. I cannot cut it. Okay, you remember this table. Okay, otherwise what I will do. Okay, let it be. So we finished calculating the cost, and also we know the k value as well. K value denote which place you have to put the parenthesis. So let us take these three matrices. Let us write the three matrix. What are the three matrix? We have four matrix, right? Sorry, here we have four matrix. So what are the four matrix we have? A1, A2, A3, and A4. So what we have to know from this k value, we have to find in which place we have to put the parenthesis. So if you say the k table, when we have the four matrix from 1 to 4, which place you have to put the parenthesis is 3. So in the matrix A3, we have to make a parenthesis. So in this place, we'll put a parenthesis. Then you see from the matrix 1, 2, 3, where to put the parenthesis. If you see here, from the matrix 1, 2, 3, where to put the parenthesis? In the place of 1. So in the place of 1, we have to make again one parenthesis, right? And then if you so A2, 3, if you see A2, 3 also you'll get, if you say what is that? A2 and 3. So if you see here 2 and 3, 2 and 3, which place you have to put the parenthesis? 2. So again 2 is an individual, right? So first we can understand, first we have to do this 2. So this 2 will be done, and then that A1 and A3, this will be done because we did already a parenthesis here. Final answer will be multiplied with A4. So this parenthesization will help us to find the minimum cost. So this is what we found. So we are finding all possible way of cost, and among that we are finding the best among that. So that is what this dynamic programming. So we have to calculate all possible way, and from the all possible way we have to choose which is the best one, right? So we chose the best one. So from this K matrix. So here we can say this is a cost matrix. See, just a name, okay? And here it's says K matrix says where we have to split it. So if I want to represent this, how will I represent hierarchically? First, what will I do? I'll multiply A matrix, and A3 is multiplied first, and this result will be then multiplied with A1, and the result which I get from here will be again multiplied with A4. This is how we will be doing the multiplication. Okay. So now we want to find what will be the cost of doing, right? So we have two matrix. This two matrix only we are first calculating with this equation, and then from that matrix only we know where to put the parenthesis. So we have to find the time complexity from this matrix. So first let us see this matrix. Let us take this cost matrix. So for the cost matrix, first time we have to do find one value. But second time we want to find two values. Third time we want to find three values. Fourth time we want to find four values. For up to four matrix, how we got the value is first time we want to find one value, two, three, four. So what is it? It is sum of n numbers. So a sum of n numbers can be represented n into n plus 1 divided by 2. So what is the higher degree of polynomial here? I'll get n square. So the cost matrix is we'll be getting big O of n square. But we have one more matrix also, right? What is the other matrix is to calculate the k value. K value means where we have to split, that also we want to know, right? So what is the cost for that? Here also if you take the k value, it is ranging from I to j. So it is like some one n values here, right? We have some k's take the value from I to j, so we can assume that it will be taking n the complexity. So for this matrix it is taking n complexity which is ranging from 1 to 4, which means I to j. So we will be taking the complexity of K matrix can be taken as n value. So when we take, when it is here we got n square, here we have n. So n into n square. So totally we'll be getting n cube as the time complexity. So we can say the worst case of the time complexity here we'll be getting is n cube. Okay. So this is how we'll be calculating, and the cost of each and every kind of parenthesis way of parenthesization. How many number of possible parenthesization? Also, I have told you with an equation, and then we have to choose the best among them. That is dynamic programming. I hope you got it. Now, what you have to do is we have to write algorithm for it, right? So how will we write the algorithm for it? So first thing is what we did is, if you see in this algorithm, this is what the algorithm. Okay, so in this algorithm, if you see this algorithm, so here we have so here we are using two matrix, one matrix we named as cost matrix, another matrix we named as k matrix. Here it is the c matrix which you told, no, that is here it is mentioned as c matrix, here it is mentioned as m matrix, and the k matrix which you use here is here mentioned as yes. That's the only thing. All the other things are same. So initially what we did in C matrix, so there all the I and j, initially I an equal number of values. Whenever the I value is 1 and 1, we initialize as 0. I hope you remember this, right? If you see here in this, so whenever 1 and 1, the value is 0. 2 and 2, the value is 0. 3 and 3, the value is 0. So whenever the I value, both the values are same from 1 to n, all the diagonal values of an INV, we initialize it with 0. And then here if you see the outer for loop, what it does represent here, it represents the diagonal initialization. Okay, so that is what represent here. So for example, what I said initially, we have to do for whichever is having the difference between is minimum, that value we calculated, right? For the diagonal values, like for the example this values first we calculated this values. Let's say this one, this value we calculated first, that is whichever having the minimum difference. Next we calculated this diagonal value, and then finally we calculated this diagonal value. So that is every time we have first time 3, then 2, 1 there, that is denoted by this outer for loop. And for everything we have to calculate the row values of it, right? Here it is 1, 2, 3, we have to calculate. So that is denoted by the next for loop. So this denotes the dimensionality and diagonal initialization, and then this in a second for loop denotes the number of row values. Okay, for each one we have to calculate, and then we are initializing this with dummy values in this C matrix. For all the values, initially it is dummy value. Say for example, let us initialize all the value of ij with 0. So that is what some dummy value will be represent. Then we know what is the k value. For we take k value which is should be greater than or equal to I, and it should be less than j, right? So for that values we have to apply this cost function. This exact same cost function is denoted here. So here there we use the notation C of I comma j. Here it is m. That's the only difference. So I k and then k plus 1 j plus. Then there we use dimensions, right? D I minus 1 dk and dj. So here this represents as p. So pi minus 1 pk and pj. And then every time we'll be checking the cost, whichever having the minimum cost, that will be that will be assigned in the matrix, cost matrix, and also that k value will be stored in the k matrix, k table there we used. Here it is yes. So that's all. Finally we have to return the value of that, this both the tables, m table and s table. Here in the example we saw it as c table and k table. So this is how we will be finding the solution for matrix chain multiplication using dynamic programming. So the only thing here we did is we have to find all possible way of combination, and then we have to find which is producing the minimum cost. That minimum cost will be taken as a solution. I hope you got it. Thank you, ma. God bless you.